Hi folks, today we're going to be going over the 15s, which is the Hydrate worksheet. First thing I want you to think about is hydrate. Hydrate means water. So if you need to hydrate, you need to drink more water. Maybe if you had some little toys like this snake right here, and you throw it in a bathtub and it grows to over 4 or 5 feet long. This is kind of what a hydrated compound is. It's a compound that takes in water. So this little snake, you throw it in the bathtub, it takes in water. The water gets locked up between the atoms and molecules of the compound it's made out of. And this would be a hydrated snake, this great big one that's right here. And when you come into the classroom, you can definitely take a look at that. So we're going to go right through the sheet, and you're going to be answering some questions as we're going along. So it says rock candy looks wet, as if some water molecules are trapped inside of it. So here we got rock candy right here. It's got sugar crystals. That's what it's made out of. How do you actually make it? You pour a bunch of sugar into a pot with some water. You start to boil it. The sugar starts to dissolve. You go over here. You let the solution cool. You drop in these sticks right here. These are just skewers, and they actually will take up some of the water and cause crystals to form at the end. You could also drop a sugar cube in if you needed to do so. You let it sit there for a long period of time, and then you start to get rock candy that forms on it. People often, I ask them, what does rock candy taste like? Well, it's made out of sugar, so it's going to taste like sugar, unless you added some kind of flavoring to it. Ionic compounds are where a metal ion and a non-metal ion. So something from the left-hand side of the periodic table with something with the right-hand side of the periodic table. Something that has a positive charge and something that has a negative charge. That's what we're talking about. Those are ionic compounds. And it says many ionic solids are soluble in water, which means that they dissolve in water. When some of the water starts to evaporate from the solution containing the ions, crystals start to grow. Many types of crystals surround or contain H2O, or water molecules, in their crystal structure. These loosely held water molecules can be driven off with extreme heat. So we could heat them up and actually get the water molecules to come loose. So if we look right here, this is very much like what the lab that you're going to do. You're going to start off with a hydrated compound. These green pieces right here, that's representing the compound. We got 4 water molecules locked up inside. Then we turn the burner flame on, and some of those water molecules are driven off. And then if we go for even a longer period of time, all the water molecules are driven off. And this is known as an anhydrous, not hydrated compound. So here we have a hydrated compound. And then here we got a process of going over to anhydrous. So anhydrous, no water. Hydrated means that it's got water in it, or hydrate. So green and purple crystals, here's just another way of looking at it. Again, we got water molecules locked up inside of it. We add some heat energy, and some of the water molecules start to come off of it. And then when all the water molecules are gone again, we get an anhydrous compound. We look down here, we started with 3 grams, we went to 2.95 grams, and eventually we're at 2.80 grams where we've lost water. So if you lose water, you lose some mass. These green crystals, so the green crystals that are right here, that green crystal contains trapped, again, H2O, or water molecules. This is a what compound? What do you call compounds that have water locked up in them? You call them hydrated compounds, or hydrates for short. Hydrated compounds are called hydrates. Okay, so that's our initial talk on that. These are all of our water molecules trapped in there. It says, how many water molecules do you see? Well, I see 1, 2, 3, 4, 5, 6, 7, 8. I see 8 water molecules. How many green crystals do I see? Well, I see one that goes this way, one that goes this way. So I see 2 of them. What is the ratio of water to compound? Well, I have 8 water molecules to 2 crystals of the water compound. So when I do that, I get 8 to 2 right here. And then if I reduce that, I actually messed up here a little bit. If I reduce that, I end up getting a 4 to 1 ratio overall. It says 4 water molecules per 1 compound. The molecule is called a tetrahydrate. So if you look on the back side of your periodic table, we have all the Greek prefixes. And if there was only 1 water molecule for 1 compound, we'd have a monohydrate. If there was 2 water molecules, it would be a dihydrate. So we're using those Greek prefixes, stating how many waters there are for every one of the compound. When the water is driven off, or when there is no water in a compound, it is called anhydrous. So again, this is a hydrate or a hydrated compound. And when we drive off all the water, we basically have dehydrated it and called it anhydrous, but we don't call it a dehydrated compound. We just don't. 1 water molecule per 1 compound molecule, that's called a monohydrate. 2 water molecules per compound, dihydrate. 3 water molecules, trihydrate. 4 water molecules, tetra, penta, hexa, hepta, octa, nona. I think you get the idea. So here again, we have 1.50 grams of hydrated compound. When we heat it up, the water gets driven off. The mass changes, so now we have 1.41 grams of the anhydrous compound, and so 0.9 grams of water were actually driven off from the compound. So now we're going to name some of these. So zirconium is element 40, so Zr is element 40 on your periodic table. What we're going to do is we're going to name this part, and then we're going to name this part. And this dot right here is not a multiplication sign. It's just a convention that chemists use. So if we're going to name this Zr is called zirconium. Taking it right off the periodic table. There's only a charge of 4 positive, so no parentheses are used. On the back side of your periodic table, we have C2O4. That's called oxalate. So the front part is called zirconium oxalate. Then we have to name the number, tetra. And then we name water, and water is going to be named as hydrate. So this would mean there's 4 water molecules locked up in for every one of those molecules in the compound. All right, pause the video and do these 2. Well, I'm assuming that you did in fact pause the video. Here are the answers to those. Niobium does have multiple charges. That's why we have to use Roman numerals. We have to state which one it is. The technetium also has multiple charges, so we have to use Roman numerals as well. So that's technetium 7 ferrocyanide monohydrate. You do, in fact, need to be able to name these. So if all you're doing is copying them down, you're not learning like you need to be doing. You need to stress your brain out a little bit, and that's how learning actually occurs. So now we have to go from the names to the formulas. So indium is element, let me see here. Indium is element 49. So indium is element 49, and that's In. So capital I, lowercase n. and it has a charge of 3 positive. Mr. Brosnan and I still write down all the charges as we're doing the problems. Dichromate is on the back of your periodic table. It is the 19th one down. That is Cr2O72-. I need to make sure that these two are playing nice so they add up to 0. So what number do 3 and 2 have in common? That is 6. So I would need 3 of these dichromates. I would need 2 of these indiums to balance it all out to 0. If the charges are too close, I would erase those with a pencil to move them off to the side. And then it says hepta, and hepta is 7. So 7, and remember we carry that great big dot that usually means multiplication sign, but it doesn't mean multiplication sign here. And hydrate is H2O. So a prettier version of that is right there. So again, please pause the video, try to do these next two rather than just copying them down. So you pause the video, that's your answer for that one. And then here's your answer for this one right here. Let me move that up for you a little bit. Okay. So 20, create a hydrate name and then figure out a formula to go with it. Have someone else look at your work to see if it's correct. So if you were in class, we would absolutely have you do this. When you create or synthesize problems, you learn the material much better. And that is all for today. So we're going to be doing a lab coming up where we're going to take these hydrated compounds, add burner heat, a bunch of burner heat to it, and drive off those water molecules. Have a good day.